All right, hello guys and girls. Today we are going to be working on lesson 4.8. So hopefully everybody had a great holiday break, winter break there. We're going to be solving problems on a coordinate grid, part 1. So our objective is we want to be able to represent mathematical problems on a coordinate grid by plotting points to form pictures and applying rules to order pairs. So if you like doing art stuff, especially or drawing, this is a great way to practice that. Apply and extend previous understandings of multiplication division and graph points on the coordinate plane to solve real world mathematical problems. All right, to get us warmed up here, okay, we have 3/5 plus 1/4. Okay, so I see there I have to have a common denominator, right? So I could list my multiples, or I just know that 4 times 5 is 20. And whenever I do the bottom, I must do to the top. So when I rewrite that one, I get 12 20ths plus. And then over here, I want to do the same thing. I want a denominator of 20. So I multiply the denominator and the numerator by 5, and I get 5 20ths. Then I can add those two together, and I get 17 20ths. Okay, so that you can do that one on your own there. So it's subtraction. Again, you do not have a common denominator. So think about 8 and 6. You could do 8 times 6, but if on evaluate they ask you to simplify, that may be a little bit tricky. So what you could do is list your multiples and find the least common, and that'll help you if you have to simplify on evaluate. So let's see, 6, 12, 18, 24. Let's see, I know 8, 16, 24. So that's my first match. So that's my least common multiple. So I know I need to make both of those out of 24. And I could do that by multiplying by 3 and by 3 on top, and over here by 4 on the top and the bottom. All right, same strategy here. So you can solve these on paper, see what you get. So with these, you can convert them to a improper fraction. Sometimes it's easier to do it that way, or you could simply borrow. So let's do 2 1/4, subtract 3/4, because that might be one that's tricky for a lot of people, or you may have forgotten if you haven't done those in a while. Okay, so I see here I got a bigger bottom, so I have to borrow. So I borrow from the 1, and I'm borrowing 4/4, which gives me 5/4. And I subtract the 3/4 from that, and I end up with, ran out of space here, 2/4. Plus I still have the 1 left over, so I have 1 2/4. So remember, a common mistake that people make is you got to make sure your numerator down here is smaller than up here. You cannot take 3 from 1 unless you're getting a negative, and we're not working with negative integers. Okay. Here's a couple more you can practice, see how you do with those as well. All right, now you want to complete Math Journal page 134. You're going to do problem 1. So go ahead and pause the video and do that, please. So as you look at number 1, find the column labeled Original Sailboat in the table below. Plot the order pairs listed in the column on the grid titled Original Sailboat on the next page. Connect the points in the same order that you plot them. You should see the outline of a sailboat. So I look at my first conjecture, and this is just your order pairs here. I see over 8, up 1. So if I go over 8 and I go up 1, I plot my first point. Then it says over 5, up 1. And you want to connect these with a straight edge. I'm not using a straight edge at the moment, but you want to use a ruler or a piece of paper or something to make it straight. The next one is over 5, up 7. So then I match it up. And again, I draw my line. Again, use a straight edge, otherwise your images won't come out quite right. Okay, then I go over 1, up 2. And again, you got to connect them in order. If you wait till the end to connect the points, you're going to have a big mess. And then over 5, up 1. So I already have that point, so I connect it. And then 0, up 1. So I go from that previous point. And again, you can start to see I'm getting a little bit off there with my drawing. Now, over 2, up 0. So I just go right there. Over 7, up 0. So I can just have a straight follow the line. and over 8 up 1. And don't judge my art skills there, but you have a sailboat. Okay, again, a straight edge will make it look a lot cleaner and sharper. So let's see. Mine looks pretty close to that. Again, they use the straight edge, so you need to make sure that you do that as well. Now, in today's lesson, you will use rulers to create new order pairs that change the sailboat. So if you don't have a ruler at home, you can just use something that has a straight edge. Okay, what does it mean, double each number of the original order pair? What do you think that means? So we know double means, to multiply by 2, right? So it says, what does it mean to double each number of the original order pair? So let's say, I'm just making this up, I have x2, y1. Well, if I was to double it, I'd multiply the 2 by 2 and get 4, and then I would take 1 times 2 and get 2. And that would be doubling the ordered pair. So it's telling you to double or multiply both parts by 2. The rule has already been applied to the first 3 ordered pairs, so let's look and see. So why does it say 16-2 in the first row? So you have to look at that and kind of decide, right? So if it says 16-2, then my guess is that it was probably originally, the original sailboat was 8-1, right? Because it told us to double it, which would give you 16-2. Okay, so if we look here, again, we have to look at the coordinates first. So we got to go back to the original. And if you go back to the original sailboat, the 4th coordinate, so 1, 2, 3, 4, over 1, up 2. So I would change that to double. So I would say over 2, up 4. And then if I go back to, let's see, the 1, 2, 3, 4, 5th one on the original sailboat, 1, 2, 3, 4, 5, it's over 5 up 1. And I have to double that according to the rule. So it'd be over 10 up 2. And so you can fill in the rest of that chart on your own there. But think about, how do you think that's going to look different from the other sailboat? If we're doubling both coordinates, do you think it's going to be a smaller sailboat or a bigger one? And why? So that's something to think about as you go through here. By answering that question, you've made a conjecture or a prediction based on mathematics about how the rule will transform the original picture. So if you make a conjecture or you hear someone say that, they're making a prediction based on the math that they have in front of them. So record your conjecture on journal page 134, then plot and connect the points for the new sailboat 1 on journal page 134. Oops. So at this point, you want to go ahead and pause the video. We already know it's going to be a sailboat, but go ahead and pause and plot your points. Remember, connect them in order using a straight edge ruler if you have one. Okay, so you're back. And so here's what, you should have your conjecture in here. So my conjecture, or the book's conjecture, was that it would look twice as big because we doubled them. And then you can see, you want to make sure your order pairs here and all your coordinates there match, and that your boat matches there. All right, so then we have the next one in a minute. So sailboat 2, how is the rule different from new sailboat 1? What happens to the second number in the order pair? So we need to look at that rule and see. If you look, it says double the first number of the original pair. Leave the second number the same. Okay, so you're only multiplying the first number by 2, and you're not going by sailboat 1, you're going back to the original sailboat. So let's look. We have the first 3 done, so let's look at the 4th one. 1, 2, 3, 4. So double the first, leave the second alone. So it would be over 2, up 2, or x, y, right? Let's see, 1, 2, 3, 4. Let's look at the 5th one on the original. So 1, 2, 3, 4, 5. Over 5 up 1, but when I double the first number and leave the second alone, I get over 10 up 1. So again, you have to go back to the original sailboat and look at those coordinates and then apply the rule. Okay, so go ahead and pause the video, fill out the rest of your coordinates, and then go ahead and plot your sailboat and make your conjecture right in here. Don't forget, what's your prediction based on those numbers? So we're doubling the x for the first coordinate, but not the second. We're leaving it alone. And look at the grid, how it's shaped too. Do you see any differences in how it's spread out? Does that make a difference in the size of the sailboat? All right, so after you've done the work, your sailboat should look like this. So the book's conjecture was it would look twice as wide. Okay, and you can see it's pretty wide. It's pretty long there, right? Because the x is the width, and the y coordinates, the second part here, is the height, and the first one, the x, is the width. So that may help you with your next conjecture. Okay, so complete the process for New Sailboat 3 on Math Journal page 134, 135. Okay, so at that point, go ahead and pause the video, and then you can check it against that. So make sure you follow the rules there. All right, so welcome back there. So if we look at the rules here, it says double the second number of the original pair. Leave the first one alone. So now you're doing the opposite, and our conjecture is that it would look twice as tall because I'm adjusting the y, which is the height, and I'm leaving the x the same. So your boat should look like that if you follow the rules for the ordered pairs. Now, how's the new sailboat different from the original sailboat? So think about that for a minute. How much bigger and why? Can you tell me how much bigger it is? And how's the second sailboat different than the original? So how much wider is it, and how do you know? And think about those rules. And then how's the new Sailboat 3 different? How much taller and why? How do you know that? All right. So each group will be responsible for one of the rules on top of journal page 136. So each of you are going to have to do each of the rules on your own. Okay. And then so if you look here, it says circle the rule for Sailboat 1 given to you by your teacher. Okay. You can choose which one of these you would like to do. So you choose one of these rules to do your Sailboat 4. So again, only pick one. Make a conjecture or prediction about what new Sailboat 4 would look like. So look at the rule that you're choosing to follow, and then make sure that you make your conjecture. So triple the first number of the order pair, and this is from the original sailboat. Triple the second number of the order pair. Double the first number of the order pair. Halve the second. So if you have it, that means you're dividing it by 2. Halve the first number, so you're dividing it by 2. Double the second number. So make a conjecture about what it will look like. Step 3, create an ordered pair for new Sailboat 4 based on the rule. Write them in the table below. Plot the new set of ordered pairs and connect the points in the order they are plotted. Was your conjecture correct? Make sure you explain. Was your prediction correct? So based on whatever rule you choose, will determine your ordered pairs. You only want to do one rule, and you're changing these based on that rule, and then you're applying the points and creating your sailboat. Remember, every time you plot a point, connect it with a straight edge. Okay, so take some time to do that. Now, how does the image when we double or triple the first coordinate, right? So how does it change when you have a coordinate? Is it going to get larger or smaller? Remember, halving it is dividing it by, make it halved is divided by 2. So in general, does an image change if we multiply or divide the first coordinate by a number? So think about that a minute. If I take the x, which is the width, if I multiply it, make it larger, or divide it, make it smaller, does that change the size of the image? How does the image change when we double or triple the second coordinate? So think about that. If we double or triple something, it's typically getting larger. So if the second one is the y, that's the height, it's going to be getting taller. But if I cut that in half, it's going to get shorter, right? So in general, does an image change if we multiply or divide the second coordinate by a number? So it changes the height, right? It would make it taller or shorter. Okay, and then you could go on to HMH and play decimal topic for practice. And that wraps up that part. And then you have your math journals pages here, so make sure you check those out as well. And you're not going to worry about the Math Masters, the home links, unless you have at home and you'd like to do that. All right, that's the end of our lesson.